come down the waterfront to see these submarines being built, it is truly a magical thing.
The ocean just swallowed the biggest submarine the United States has ever built.
It's the stealthiest submarine that the U.S. Navy has ever produced.
It is the length of 2 football fields. It is heavy, it is fast, and it is totally silent. The District of Columbia is the start of a new era. While everyone is talking about the nuclear missiles, the real wow factor is the electric motor that turns it into a deep sea ghost. Rival nations are pouring billions into sensors, but they are looking for a shadow in the dark. This is the ultimate insurance policy, and the details are truly terrifying. The Phantom Empire State. What many people overlook is the other secret sub-program, the SSN-X, that is coming right behind it. To understand that, we have to look at the Columbia class first. Imagine the Empire State Building. Now lay it on its side and slide it under the Atlantic Ocean. Do it without making a sound, without a splash, and without a single wave. The ocean just swallows it whole. In the quiet that follows, the single most terrifying machine ever built by humankind begins its patrol. This machine isn't built to fight a war. It is built to prevent one simply by existing. Because the threat it carries is so total and so final, it makes the idea of a large-scale conflict unwinnable. This is the USS District of Columbia, the very first of the brand new Columbia-class ballistic missile submarines. And to put it mildly, it is a ghost that carries thunder. For decades, the United States has relied on its Ohio-class submarines. These were the ultimate Cold War deterrent, silent and powerful. But here is the deal. They are getting old. They were built in the 1970s and 80s, and they are reaching the end of their service lives. More importantly, their nuclear reactors need a complicated and expensive checkup and refueling about halfway through their life. This midlife makeover takes the sub out of the water for years, leaving a hole in the nation's defense. The Navy knew it needed a replacement, but it didn't just want an upgrade. It wanted a leap. The result is the Columbia class, and the numbers are just staggering. This isn't just a warship. It's a moving underwater fortress designed to stay hidden for months at a time, completely ready to act at any moment. She weighs in at over 20,000 tons and is 560 feet long. That is almost the length of 2 American football fields. Her width is 43 feet. This makes her the largest submarine the United States has ever even tried to build. The price tag matches the power. The lead ship, the District of Columbia, will cost about $18 billion. Each of the 11 sister ships after her will cost around $11 billion. To build something this massive, the Navy had to turn to its 2 most famous shipyards. General Dynamics Electric Boat in Connecticut and Newport News Shipbuilding in Virginia are working together. It is a team effort. Each yard builds huge, complete sections of the submarine. These sections are then floated to one location and joined together like the world's most complicated and high-stakes puzzle pieces. But the real wow factor, the part that has other countries terrified, is deep inside its hull. At the heart of the Columbia is a brand new S-1B nuclear reactor. This reactor is a marvel. It is designed to power the submarine for its entire service life. We are talking about more than 40 years without ever needing to be refueled. Think about that. The Ohio-class subs had to come home for years. The Columbia never has to. From the day it is launched to the day it is retired 4 decades later, its power source is good to go. This single change dramatically increases its availability, saving an estimated $40 billion in support costs over the life of the fleet. But the reactor lifespan isn't even the scariest part. It's how it uses that power. You see, this reactor creates a massive amount of steam, which spins turbines. In older subs, those turbines would connect to a set of massive, complicated reduction gears that would then spin the propeller shaft. Those gears, no matter how well made, clanked and whined. That gear noise was the sub's fingerprint. It was the sound enemy sonar operators would listen for. The Columbia has no gears. It is the first American boomer to use a full electric drive. The nuclear core turbines spin a generator, creating a massive amount of electricity. That power is then fed quietly to a huge electric motor, which turns the pump jet propeller. Fewer moving parts mean less noise, less maintenance, and a sound that just blends into the ocean's natural background hum. To an enemy listening, the sub doesn't sound like a machine. It sounds like nothing. And then there is the payload. Under her deck, the Columbia has 16 massive launch tubes. Each silo holds a Trident II D5LE missile. The LE stands for Life Extended, and these are, to put it simply, planet enders. Each missile has a range of over 7,000 miles and can carry multiple independent re-entry vehicles. This means one submarine, hiding silently and untraceably anywhere in the world's oceans, can strike over 100 different targets on any continent with pinpoint accuracy in under 30 minutes. The Ohio class that came before it actually carried 24 missiles. The Columbia only carries 16. This sounds like a downgrade, but it is not. It is a sign of smarter, more efficient design. The Navy learned that 16 missiles is more than enough to provide a terrifying deterrent. And by reducing the number, they made the ship quieter, more advanced, and more survivable. The missile compartment itself was designed in a historic partnership with the United Kingdom, which will use the same compartment for their new dreadnought class of submarines. What many people overlook is the purpose of this ship. It is not a hunter. It is not an assassin. Its job is to disappear. It will leave port and for 90 days or more vanish from the face of the earth. Its only job is to stay hidden and wait for a command that everyone hopes will never come. It is the nation's ultimate insurance policy. For a rival power, this is a nightmare. Their admirals know this ghost is out there. They know it could be 500 miles off their coast or just 50. They can pour billions into their own sonar nets, their own hunter subs, and their own spy satellites. But they are searching for a whisper in a hurricane. They are looking for a shadow in the dark. The Columbia class ensures that no matter what happens, no matter how a conflict might start, the United States always has the last word. And that word is devastating. But this doomsday fortress is only half the story. The Navy is also building its assassin. The real terror begins when the silent giant meets the hunter that never misses its mark. This Phantom is just the beginning of a much larger plan to control the deep. The artificial intelligence predator. While the Columbia class is built to hide and wait, the U.S. Navy is working on its polar opposite. They are building a submarine meant to hunt. It is a purebred predator, an assassin designed to find and neutralize the enemy's most valuable ships and submarines right in their own backyard. Right now, it just has a code name, SSN-X, or Attack Submarine Experimental. But the X doesn't mean it is just a test. It means it is the next generation. Basically, it is the shark of the future. To understand why the SSN-X is so revolutionary, you first have to look at its older brother, the Virginia class. The Virginia subs are the current workhorses of the Navy. They are by any measure incredible machines. At 377 feet long and weighing nearly 7,800 tons, they are fast, powerful, and very, very quiet. They were designed after the Cold War ended, so they weren't just built to hunt other subs. They were built to be a jack of all trades. The Virginia class has some truly mind-blowing tech. The most famous is the photonics mast. For 100 years, submarines had to use a periscope. This was a long steel tube full of lenses and mirrors that had to physically poke out of the water. The problem was that the periscope had to go into the control room. This meant the control room had to be in the cramped upper level of the submarine right under the sail. The Virginia class has no periscope. Instead, it has photonics masts. These are high-tech camera towers that can see in high definition infrared, and low light. They send their signal through a fiber optic cable. This means the control room is no longer tied to the hull. Engineers moved it down 2 decks into a much larger, more open space. The crew said it was like going from looking through a tiny straw to watching a giant widescreen IMAX movie. This move also made the sub safer, as the command center is now in the most protected part of the ship. The Virginia subs are also armed to the teeth. They have 4 torpedo tubes for the heavy Mark 48 torpedoes. These are designed to track other subs or break the back of a large warship. But up front, they also have 2 massive 87-inch payload tubes. Each of these tubes can hold 6 Tomahawk cruise missiles. These are long-range weapons that can fly over 1,000 miles to hit a single building on land. A Virginia sub can also use these tubes to launch Navy SEALs in a mini-sub, or deploy unmanned underwater drones. It is the ultimate multi-tool. But here is the thing. The world has changed again. The focus isn't just on coastal operations and special forces anymore. We are back in an age of great power competition. The Navy is once again planning for a potential conflict in the deep open waters of the Pacific or the North Atlantic. And for that, it needs more than a multi-tool. It needs a shark. That shark is the SSN-X. The SSN-X is being designed to take the best parts of all its predecessors. The Navy wants it to have the speed and payload of the old hyper-powerful Seawolf class, the silence and advanced sensors of the Virginia class, and the never-refuel reactor of the new Columbia class. It will be a monster, weighing over 10,000 tons. It will be the quietest and fastest hunter submarine ever built. But its real power won't come from its torpedoes. It will come from its brain. The SSN-X is being designed as a deep-sea mothership. This is where the future starts to look terrifyingly real. Imagine this. A conflict is starting in the South China Sea. An American SSN-X sits 100 miles away from an enemy fleet, submerged 500 feet deep and making 0 sound. Its torpedo room isn't just full of torpedoes. It is a horizontal payload bay, and it is reconfigurable. The sub launches a swarm of 50 unmanned underwater vehicles, or UVVs. These drones are the sub's robot wolf pack. They spread out, communicating with each other on a hidden network. Some are small scouts just listening. Others are decoys moving forward and daring the enemy to find them. A few are larger, loitering drones, and they are carrying their own torpedoes. The SSN-X itself never makes a sound. It never pings with its own sonar. It just sits back 100 miles away and listens through its drones. Its revolutionary new battle system is powered by artificial intelligence. It takes in terabytes of data every second from this entire swarm. It processes the sonar signals, the magnetic signatures, and the water pressure changes. Then, it paints a perfect 3D picture of the entire battlefield for the commander. The AI identifies the enemy's prized aircraft carrier and its destroyer escorts. The commander, sitting in a quiet control room, gives the order. The SSN-X doesn't fire a single weapon. Instead, it beams a command to the wolf pack. 20 miles away, the loitering UUVs spring to life, acquire their targets, and launch their attacks. The enemy fleet is thrown into chaos. They are hit from multiple directions at once by weapons that seemingly came from nowhere. They search frantically for the submarine that attacked them, but there isn't one. The real attacker, the SSN-X mothership, is still 100 miles away, totally silent. It recalls its surviving drones and slips away into the deep. This is decision superiority. It is the ability to see, understand, and act before the enemy even knows they have been seen. This is the future of underwater war. The SSN-X won't just be a hunter. It will be the unseen quarterback of a robotic undersea army. But how do these machines actually hide? The secret is not just about being quiet. It is about becoming a hole in the water that sound cannot find. The science behind this invisibility is what truly keeps rival navies awake at night. The physics of a ghost. How do you make a 20,000-ton, 560-foot-long piece of steel completely disappear in the middle of the ocean? It sounds impossible, but it is a science that the Navy has been perfecting for over 70 years. The bottom line is, you have to defeat the two ways an enemy can find you: active and passive sonar. First, let us talk about active sonar. This is the one everyone knows from the movies. It is the ping. An enemy ship sends out a powerful pulse of sound energy. That sound travels through the water, hits the submarine, and then bounces back to the ship. The ship listens for the echo. This tells them your direction and your range. It is like shouting in a canyon and waiting for your voice to come back. So, how do you beat the ping? You have to stop the echo. Modern submarines like the Virginia and Columbia are covered in thousands of special anechoic tiles. These are not just simple rubber mats. They are high-tech, multi-layered synthetic materials. They are a top-secret part of the sub's design. Each tile is individually and painstakingly glued to the hull. Their job is to absorb sound energy. When that enemy ping hits the sub's hull, it doesn't bounce off. It gets trapped in the tiles. The sound energy is converted into a tiny amount of heat and just dies. To the enemy sonar operator waiting for a loud echo, he just gets nothing. Just silence. The sub has effectively become a black hole for sound. The hull is also shaped with special curves and angles. These are designed to deflect whatever tiny bit of sound does bounce, sending it away in a random direction, not back to the listener. But here's the thing. Most submarine hunters do not like using active sonar. That loud ping instantly gives away their location to every other submarine in the water. So, the real game is passive sonar. Passive sonar is just listening. It is a game of ultimate quiet. The hunter sub and the surface ships just drift, listening with incredibly sensitive underwater microphones. They are listening for the tiniest sound that doesn't belong. The hum of a motor, the whine of gears, or the pop of a propeller. This is the real art of silence. And this is where American subs are unmatched. Beating passive sonar means finding every single thing on the sub that makes noise and silencing it. First, the propeller. An old-fashioned fast-spinning propeller has a big problem called cavitation. As the blade spins, it creates tiny vacuum-filled bubbles in the water. These bubbles then collapse with a small pop. Billions of these pops create a unique humming sound signature. An experienced sonar operator can hear that sound and know exactly which class of sub it is. The solution is the pump jet propulsor. This is not an open propeller. It is a complex set of blades that sit inside a large, carefully shaped duct. This duct channels the water, smoothing out the flow and preventing those little bubbles from forming. The water is pushed out the back in a powerful but almost silent stream. The sound it does make is at a frequency that is very hard to tell, apart from the ocean's own background noise. Second, the machinery. A nuclear submarine is a living, breathing factory. It has air conditioners, pumps for coolant, generators for electricity, and CO2 scrubbers for the air. Every one of those machines vibrates. If they were bolted directly to the sub's hull, the entire submarine would hum like a giant tuning fork. To stop this, engineers use rafted machinery. The entire propulsion system, the reactor, the turbines, and the generators are not even touching the main hull. It is all built onto a massive internal raft. This multi-ton raft is then suspended from the main hull by a series of massive flexible shock absorbers. Any vibration from the machinery goes into the raft, but it never reaches the outer hull. It cannot get into the water. There are other even sneakier ways to hide. An enemy might be looking for a magnetic signature. A huge chunk of metal like a submarine disrupts the Earth's natural magnetic field. A plane flying over with a magnetic anomaly detector could spot this. To counter this, subs are degaussed. They are wrapped in electric cables and zapped with a current that resets their magnetic signature. This makes them magnetically invisible too, and the ocean itself provides hiding places. The water is not uniform. It is made of different layers of temperature. A thermal layer, where cold water meets warmer water, can act like a mirror for sound. A submarine commander can dive just below this layer. An enemy ship, pinging from above, will find their sonar hits that thermal layer and bounces right off. They are completely blind to the sub hiding just beneath it. This level of technology feels like it came from the future. But the truth is, it did not happen overnight. It was all learned piece by piece during decades of a secret, silent war. This technology was paid for by the lessons learned from the old guard who patrolled during the Cold War. These early pioneers faced dangers that the new fleet has spent billions trying to erase. Before the Columbia, and before the Virginia, there was another shadow cutting through the seas. It was older and a little louder, but for its time, it was an unstoppable force. Her name was the USS Los Angeles. She was the first of a line of 62 submarines that defined underwater power for a generation. When she launched in the mid-1970s, the world was split in two. The Cold War was at its peak. Every ocean was a chessboard, and Soviet boomer submarines were silently patrolling, holding America's cities at risk. The U.S. Navy needed a hunter that could match them, stroke for stroke. The Los Angeles class, also known as the 688 class, was that hunter. She was not the biggest at only 362 feet long, but she was one of the fastest and quietest of her time. The official numbers said she could dive deeper than 650 feet and go faster than 25 knots. But everyone knew those were just polite numbers for the public. Her real speed and depth were classified secrets kept only by the crews who sailed her. This was the era of cat and mouse. This is where the real drama of the movies came from. A 688 class sub would pick up a new Soviet sub leaving port and stick to its tail. They would do this sometimes for weeks at a time, often deep under the Arctic ice pack. The tension was unbelievable. American sonar operators would sit in a dark room wearing headphones, listening for the faintest sign of the sub they were hunting. They were listening for a wrench to be dropped or a single loud command. Does building a more silent, more powerful weapon actually make the world safer, or just make the stakes of the next conflict terrifyingly higher? Let us know below. Like and subscribe.